Hello friends, I'm Professor Swanan Dongre, and in this lecture, in this video, we are going to see the different operating regions of transistor depending on the biasing conditions of PN junctions and the application of transistor in that region of operation. So we have seen that in diode there is only one PN junction, and this PN junction can be either forward bias or it can be reverse bias. So if that PN junction is forward bias, means if anode of that diode is at higher potential as compared to cathode, then that diode is forward bias and it acts as a closed switch, on switch. If the anode is at lower potential as compared to cathode, then the diode is reverse bias and it acts as an open switch, off switch. In transistor, there are two PN junctions. One is between emitter and base, and second PN junction, it is between collector and base. So this emitter base junction, it is simply called as emitter junction. Collector base junction is called collector junction. As there are two junctions, PN junctions in transistor, so that is why there will be four combinations. Either both junctions can be forward bias, both can be reverse bias. First is forward bias, second is reverse bias, or first is reverse bias, second is forward bias. These will be the four combinations. And based on these four combinations, we are having different regions of operations, operating regions of transistor. And in each region, transistor has different function. Now let us see first the biasing of emitter base junction. Then second is collector base junction, right? Then the region of operation, and that is operating region, and last one is the application, right? First case, both the junctions are forward bias, FB means forward bias. Then second case, both the junctions are reverse bias, RB means reverse bias. Then third, emitter base junction forward bias and collector base junction reverse bias. And fourth combination, the emitter base junction is reverse bias and collector base junction is forward bias. So these are the four combinations. So first, if both the junctions in transistor are forward bias, that is emitter base junction as well as collector base junction, both are forward bias, the region of operation of transistor, it is saturation. It is saturation region. And in saturation region, the transistor acts as an on switch, that is closed switch. If both the junctions are reverse bias, then transistor operates in cutoff region. And in cutoff region, the application of transistor, it acts as an off switch, that is open switch. So these two combinations are very easy to remember. Both are forward bias means saturation, on switch. Both are reverse bias, cutoff region means off switch. Now the confusion is in between remaining two cases. So here, how to remember? If emitter base junction is forward bias and collector base junction is reverse bias, then this region of operation, it is active region. And in active region, the transistor acts as an amplifier. This is very important application of transistor. In active region, transistor acts as an amplifier, and we get the active region of operation when emitter base junction is forward bias, collector base junction is reverse bias. How to remember this? In ABCD alphabets, after E we are having F, A, B, C, D, E, F. So emitter base EB, forward bias means FB, E, F, EB, FB, that's it. Emitter base forward bias, collector base reverse bias. Then it is the region of operation is active, and in active region transistor acts as an amplifier. Now the fourth combination, that is emitter base junction reverse bias and collector base junction forward bias. And this region where emitter base junction is reverse bias, collector base junction is forward bias, it is called reverse active. Reverse active. Because here the biasing conditions, they are opposite to the active region. So that is why it is called reverse active region. And in reverse active region, it is not having any application. It is not used practically. Right? Though we have changed the biasing conditions of these two PN junctions and those are reversed to the active region, but in transistor, at one side of base the doping is more and at one side another side the area is more, so there is no symmetry. Hence that is why by just changing the biasing conditions of this emitter base junction and collector base junction from forward bias to reverse bias to the reverse bias to forward bias respectively, we can get the amplification. So that is why this region of operation it is not used practically. So these are the these are the four cases, but out of these four cases we can use only three cases. Both junctions are forward bias, both junctions are reverse bias, and third condition, emitter base forward bias and collector base reverse bias. And the regions of operations are saturation, cutoff, active. In saturation region, transistor acts as an on switch, close switch. In cutoff region, transistor acts as an open switch, off switch. And in the active region, transistor acts as an amplifier which converts small amplitude signal into large amplitude signal. Thank you.